Let's implement the Quicksort algorithm in C#. This is Daniel, and you are going to get coded. Here I have Visual Studio open, and let's try to create a simple console application to demonstrate this. So, File, New Project. Under Visual C#, Windows Desktop, I'm going to choose Console Application, and then I'm going to name this Quicksort, and then hit OK. While this is loading, I have again the link opened over here, and you can find the link in the description down below. So, a warning before we start. This is just a demonstration of the Quicksort algorithm. So, .NET, which is the framework for C#, comes shipped with a sorting method for arrays called array.sort. So in essence, you don't need to implement this from scratch. You don't need to reinvent the wheel. You don't need to even watch the whole video. You can use just array.sort. But there are many students at college, university, school, professors, I don't know, people who need actually to know how to implement Quicksort. And this video is the right video for you. Also, I'm going to implement or to create an experiment comparing this very algorithm with Microsoft's. So I'm going to make a comparison between these two and see actually how they perform. So it's going to be a performance and speed comparison between these two algorithms. So I just put that outside. This is the warning. This is just a demonstration. If you don't want to implement it by hand, manually, you can implement it. You can use array.sort. Okay. So let's start with an array of integers. This is an array of numbers, so just some random numbers. And then I'm going to display it to the console by using a for each. So nothing fancy, nothing special here. And I'm going here to scroll to the right a little bit so that you can see the whole code. And let's try to actually start implementing. So var numbers is going to be new square brackets and then curly braces, and I will try to keep the numbers that I have there, so to not deviate from the post and to have the same results as in the post. And then I'm going to use the for each to actually print to the console each item, and I'm going to rename item to number, so number and numbers. I'm going to iterate over numbers and then CW tab. This is going to print out number, and this just got to the left. I will still try one more time. Hopefully this won't jump again to the left. Also, I'm going to print to say console.read key, and this very line is going to wait for us until we press any key, so it keeps the console opened. So let's try to press F5 and actually see the actual result. And hopefully we see the array. So all the items in the array are printed to the console. So nothing fancy, again, just a simple array and a simple for each. So let's stop the execution, and I'm going to continue. So let's create a function called sortArray to which we can pass this array. We could make this as an extension method if we so desire. So if you don't know what an extension method is, in essence, it is a method, obviously, which you can call on an object. So by default, this numbers array doesn't provide us a sort array method. But when you create an extension method, you can say numbers dot sort array or what have you, the name of your own method, and that will work. So you don't need to go inside the class and add the method there. You can make an extra class and you can do something like that. If you want to know how this can be implemented as an extension method, please click thumbs up. If this video gets to maybe 30 likes, I'm going to transform this to an extension method. So consider liking this video. So nevertheless, press Ctrl and dot to generate the method or the function. And before we move forward, let's try to put this out of the way. So methods and functions. Because we work with C#, this is an object-oriented programming language. And all the functions are called methods because they are part of a class. In our case as well, and I need to scroll to the left, we have a class program which has a main method. Okay, so we have methods because we work in C#, we work with classes and so on. But the idea of this video is to actually show you like Quicksort, and this is why I say function. Function, when you use function, it is like a small bit of implementation. Like this is what you should think of functions. When you think of methods, it's something related to a class. Okay, so there is a very subtle differentiation, but you need to make sure that you are aware of that. So I'm going to generate that method. I will not write it by hand. And I'm going to, and you see it won't stay at that position, so leave that like this. So I'm going to say sort array. So I'm going to create this method, and then I'm going to pass numbers. And you can see that I have a red squiggly line underneath the method. And this means that the method doesn't exist. So let's try to create it. I'm going to press Control and left key to move faster, so afterwards, and then Control and dot, generate method. And this method is generated. So this is going to actually be our first function, first method, which we are going to call. And these look the same. Inside it, I'm going to call a Quicksort function, to which I pass three things. So the array, the beginning of the array, and the end of the array. So you can see here, I create another function, another method. I'm going to use method from now on. Numbers 0 and numbers dot length -1. So we need to pass obviously the array. We need to pass the beginning and the end. So let's try to do this. So instead of throw new not implemented exception, I'm going to say Quicksort numbers 0 and numbers dot length -1. So let's do the same. I'm going to press home and then Control dot generate method. And I don't want to keep these variables like this. So I don't want v1 and v2. I want left and right. So left and then right. Okay, so this is good. Also, I have one small tip here. This is a good coding practice to have functions that implement isolated things. So you can see right now we have two functions, two methods, and also the main method. So in the main method, we are initializing, we are actually initiating the process, the algorithm, the program. And then we have two methods. So we are trying to break down our algorithm into two methods in this example. So this is what you should strive for. You should not strive to have long methods because they are very difficult to maintain, very difficult to test, very difficult for others to read and to go through. And a rule of thumb is to actually not have a method which is longer than the window. So not longer than this. So this is a very nice approximation, and also make sure that you don't have 135% zoomed in. So a normal size, so 110%, and should not, so the lines inside this method should not reach or go beyond the height of the window. So just a small tip for you to know. You are welcome. So implementation. From now on, we are going to implement the Quicksort algorithm. So the Quicksort algorithm is going to be implemented here. So this is the actual magic. I must say that I don't know this by heart, and you shouldn't either. And this is the idea. You should not strive to remember things from scratch by heart, and to implement them from scratch if they are already provided by the framework, but also don't learn them by heart. Try to understand, and try to just like understand what steps you need to implement, what variables you need to implement, and you have to implement. And you can just find a good resource, a good implementation, a clean and elegant implementation. I believe mine is a clean and elegant implementation. So you can just search Google and find it. So the idea is to understand what I'm going to do here. And also, the aim of this video is not to show you or not to explain how Quicksort works. There are plenty of resources on the internet, plenty of videos on YouTube that can teach you just that. and with graphics and design and all those things. So consider watching some videos on YouTube. Just try to search Quicksort and you'll find pretty short videos of how to actually think about Quicksort. So the aim of this video is not to actually explain Quicksort, but implementation. So how to implement it in C# and how to break it down into functions, into methods. And also I'll try my best to actually explain. So I will provide you an explanation, but it's not going to be a complete explanation of what Quicksort is. So you need to complete this with another video. So let's try to see how this Quicksort works. I'm going to explain line by line, so everything. I will not mess you up. So every single line I'm going to explain. So when you think about Quicksort, you have a pivot. This pivot is an item. And this item is at the center, at the middle of your array. And this pivot breaks or splits the array into two parts. So you have the left part and the right part. So the left array and the right array. And the idea here is that on the left side, so in the left array, you don't want to have items that are greater than the pivot because they don't belong here, they belong on the right side. And the same goes for the right side. If you have items on the right side that are less than the pivot, and you can think of this microphone as the pivot, and here have items. So if these items are less than the pivot, then they don't belong here. They belong in the left side of this microphone, of this pivot. Okay? So this is what we are trying to do. We are trying to actually go from the beginning of the array and from the end of the array, so from both parts. And we are trying to see the items that don't belong in those parts. And we are trying like to see one by one. And if we find one, we are going to swipe it or to interchange it with the pivot. So an item and the pivot. And this is another idea that you should remember. So the first one, the pivot, splits the array in two parts. So you understand the left side and the right side. So, okay. Let's move on with the second idea. So the second idea is to actually understand like how this works. So you need to implement swapping, and you can find swapping over here. So in essence, it's just an implementation of how to interchange two values. So you have two values in the array, you need to interchange them. Okay, so value 1 gets the value from 2 and 2 from 1. In Quicksort, one of them has to be the pivot. So we are either trying to find an item in the beginning in the left side. So we check, is this item greater than the pivot? Yes, it is. We will stop, we will take this item, we will save the index, and then we will try to go with the j. We are going to go with the j until the pivot, and then we swap them. So this is what we do here. So we swap these two. And again, on this side, we swap. But I'm going to set breakpoints in the code in Visual Studio. So I'm going to use the debugger and to show you like the actual values. So don't worry if this still is just confusing. I will do that as well. So we are going to see all the values that are on in those variables. So we need two variables, I and j, the beginning and the end. And then the pivot. So this pivot gets this specific, and I think this is a little bit too small for you. I don't know. Let's try to do it like this. So the pivot, and this is just an average. So this is just a simple average. Left and right divided by 2 /2. And then you have a while I is less or equal than j. So it doesn't make sense that the I goes beyond j. So the I starts from the beginning, the j starts from the end. So we want to increment I and decrement j until we are at the pivot. So we increment and we decrement. And once we are here, then the array is sorted. If this I goes beyond j, then we have gone too far. So this is way too much. So this is just a condition that we need to comply with. And then we have here two loops. As I said, we need to check the item to see if it's less than the pivot. If it's less, we are going to increment the I. So, is this item over here less than the pivot? Yes, well, it's fine. it is where it's supposed to be. It's supposed to be on the left side. So we are going to increment. Next one. Is this less than the pivot? Yes, it is. Cool, amazing. This is where it should be. Increment it again and again and again. So we are going to increment it until we find an item over here which is greater than the pivot, meaning this specific item should not stay here, doesn't belong here. Or if all the items here are good, are less than the pivot, we are going to increment the I until pivot, and we are going to stop. So the left side is sorted. We can move on. And the same, but in the reverse order, happens for J. So J starts from the end of the array, and it goes down, 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 down. The same thing, it checks to see if this item is now less than the pivot. If it's less than the pivot, it doesn't belong here. It stops here. The I goes to pivot, and we are going to interchange them. So this is going to be like this. Okay. And then we have an if statement again. We need to make sure that we don't go too far. So a while and an if. And then we have a swapping algorithm. So this is a very traditional algorithm that you'll find in school or in earlier days of programming. So this is how you swap two variables, because if you just do it straightforward, you'll lose the variable, and I'm going to show you in the debugger. And then I++ and J minus, increment, decrement, so simple. And the last part, we need to see where should we go. Should we go on the left side, or should we go on the right side? Should we go in the left array or in the right array? And this is what these two conditions actually check for. And then we are going to call the function again, so the method again. And you can see that this one is the same name, so we are going to call this again. And whenever you see a calling like this inside the body of a method, this is special. This is called recursion. So whenever you want to call, or whenever a method or a function calls itself, we can say about that function that is a recursive function. So we implement here a recursion, and we pass only that small part. So we don't pass the whole array from the left, or the whole array left to right. We just want to pass a small portion, so just a subsection, and we are going to implement, or not to implement, but we are going to apply this algorithm again for this subsection, and then subsection. So let's try to implement this. So I'm going to start by typing int j and int I and j. So left and right. And then I'm going to write pivot. So numbers. This is the average, so the average between left and right. Also, I've seen that you can say left plus right minus left, something like that. You can explain to me why you need to do this, but I think, and this is what I strive again for, I want my code to be clean, easy to understand, and just straightforward. So I don't think you can achieve a lot if you do that. So I is less or equal than j, and we are going inside. So we have two loops. So while numbers I, so while that item from the left is less than the pivot, then we are going to move on, just move on. While the item is greater than the pivot, and instead of I need j. So make sure that you put all of them in the right spot. And then j minus minus. So we increment j, we increment I, we decrement j. And then we have the if statement. So if the same condition, I is less or equal than j, we need to have TMP. You could name this TEMP or temporary variable, I don't know. But this is how many developers implement this. So numbers I, numbers j, and then numbers, and then TMP. So how to remember this? You need to start with the temporary variable, so TMP. and then the first one, second one. So numbers I, numbers j, and then you assign. So TMP, the first one and the second one. And this is how you can remember how to implement swapping, because sometimes you might forget, like, should I start with the second item or with the first one? No. So you start with the temporary, temporary gets the first gets second, second gets temporary. Okay? And then I plus plus j minus minus, we need to move on in both sides. So I plus plus and j minus minus. Also, you can press escape if you want to close the IntelliSense. Sometimes, in this case, for example, I want to close it. So escape. And this will close the actual IntelliSense. Okay, and we have one more, like these two conditions, one more section, but you need to make sure that you are outside of the while loop. So these are outside. These curly braces are here, so we need to go outside of this. So if left is less than j, we need to call Quicksort, so we need to call this very method again, but with only that subsection, so only the left part. And then if I is less than right, we are going to say Quicksort, and I put an extra semicolon. I'm going to remove this. So just like this, and we don't need this one. We need to end this with a semicolon, and we need to press Ctrl KD if you want. This will just format all your code. So again, Ctrl KD, this is the formation, this is the formation. This is how you format the code. So this is the actual implementation. It's not that much actually. So yeah, so let's try to press F5 and see the actual result. And indeed, we have all the items in the right order. So the array is sorted. Amazing. So let's stop the execution. I'm going to set the breakpoint. So I'm going to put a breakpoint here. I'm going to expand this one, and let's try to press F5. And we are going to look in the locals window, and we are going to expand numbers. So right now, numbers, all the numbers are unsorted in the way we just initialized the array. So F11, we go inside, so we step into the code, and then we need to go inside here. So the I gets 0, j gets 5, and then pivot gets 0. So the item in the middle is actually 0. And one thing to remember, we have an even number of items in the array. So we have 6. If you have 6, then the middle is going to be like 0 and 34, but we are going to get the first one. So this is the pivot right now. When you have odd numbers, or not odd numbers, but the total number of items is an odd number, then it's going to be right in the middle. Okay, so even and odd numbers is how they work. So we need to check this condition. This is obviously good. And we need to check the item. So right now the I is 0. So at index number 0 we have 1. Is 1 less than the pivot? So this is the pivot. No, it's not. So this doesn't belong here. And we are not going to increment the I because we have found 1. And we are going to do the same for j. Is 9 greater than 0? Yes, it is. It's good. Let's move on. Is 3, and you can see j decreases. Is 3 greater than 0? Yes, it is. It's in the right spot, in the right array. Is 34, so the item from index number 3 is 34. So j is 3 here. 34 is greater than 0? Yes, it is. And we are going to press F11 again. Right now j is 2. Is 0 the pivot greater than 0? No. So we have found the pivot. So right now these two indices here point to two items. The item that we want to swap, 1, and the pivot. So this is like the secret thing. One of them, either one, has to be the pivot. So one of them has to be the pivot. And then the other one has to be an item. And we are going to swap them together. So we are going to check again to make sure that we have not passed too much. And then we have this TMP variable and the swapping. So let's try to swap them. So TMP gets 1. You can see right now, first position 0. And then the third position, so index number 2, is going to be 1. So we have managed to swap these. So it's amazing. This works. I++, J-, we move on. And then we are going to check one more time because we have this equality here. And this is not going to do anything because they are equal right now. Okay, so now the question. In what part should we go? The left side or right side? So on the left of 0, we don't have anything. So we cannot go there. So we are going to go on the right side. And you can see here, so we don't go on the first branch, but we go on the second, like not branch, but second if statement. And we are going to call again this method, but only with that subsection. So the I is 1 and the right is 5. So from 1 to 5, only this subsection of the array. And if we press F11 again, you can see that we go again up in the method and we start all over again. And we are going to continue only for that specific part. So even though we have the same numbers, so all 6 of them, these indexes dictate the subsection of the array in which we still need to sort. So the pivot right now is 34. So let's see why. The I is 1, so index number 1. The J is 5, so the middle is 34 indeed. So right now the pivot is that one, and we are going to check. Is 5, so index number 1, 5. Is 5 less than the pivot, less than 33? Yes, it is. 34. Yes, it is. It's on the right side. On the not on the right side, but on the left side. It's good. So we can press F11. We continue on. Is 1 less than 34? Yes, it is. So it's on the left side. It's good. It belongs there. And then I gets 3. So we have reached the pivot. Right now, this condition is not true. So we have reached the pivot. Everything on the left side is sorted. Let's look on the right side. So I'm going to press F11. Right now J is 5. Is 9 greater than 34? No, it's not. We need to move that from here. This doesn't belong here. So we need to check this one more time to make sure that we have not passed too far, because if we do, it's going to be like way too much, you know? So you are going to have an exception if I gets beyond J. So let's swap them together. And also keep an eye on these values over here, because I'm going to show you like what's the meaning of this swapping. So if I press F11, you can see that temporary variable gets 34, and we have 34 here. But right now we swap these two, so 9 with 34, and 9 and 34 is not in the array anymore. So if we don't have an extra variable to hold that outside of the array, we have lost it. We lose this item. But because we have it in an extra variable, in an external variable, we can just assign it. So this is the actual meaning of swapping. And then I++ and J-, we increment the I, we decrement the J, meaning we move forward. We move forward, we move inside the array. So again, this is the mindset of Quicksort. You go inside. And also, one good thing to have in mind about Quicksort, and sorry about that, is to actually think about it as a tree structure. So a tree structure and a binary tree. So you have the array over here, and then the array is split into 2 parts. And then these parts are split into 2 parts and 2 parts and so on. So you have like a tree structure, and you are going to split your array until you have on one level only one item. So you have a parent with 2 children. So on one branch, you have only one item. So this is like the mental representation of the Quicksort, and maybe this helps you to think about like how this works. And once everything is just layered on branches, everything is going to be put up again in one line. And this is like the sorting. But again, check the YouTube check YouTube videos to see actual like explanation of Quicksort. So we are going to check again for I and J. These two are good. And we are going to go on the left side this time, because there are items on the left side which are not, which do not belong there. So this is the actual thing. I'm not going to continue with this because this is going to repeat for each item. So I'm going to press fast right now, F11. So you can see right now the pivot is 9, so the middle, and we are going only in this part. So we don't care about 0 and 34 anymore. So these two are good. We want to go inside. So we want to go in this subsection of the array. And we need to press F11 again. And you can see that right now we try to swap the item from position number 3, which is 9, with 3, the item from the position number 4. And if I continue with F11, you can see that these two are swapped. So this is going to be called for each one of them. So you can see the array is going to be changed with all the items. So let's try to set a breakpoint, I think, on this line, and I'm going to continue. And right now all the items are sorted, so 0, 1, 3, 5, 9, and 34, all of them. And you can see all of them printed to the console over here. So this is the implementation of Quicksort. Let's try to see the conclusion of this video. So you might want to sort arrays of type char, string, or even a custom object. Well, these functions won't work because they are only for integers. So you can see we have int and int. But with the power of generics, they can, which is coming up next. So the next video is going to be about generics and how we can transform this so that we can pass an array of characters, an array of strings, an array of objects, of cars, of cats, anything you like to this, and this is going to sort it. And one small note before I end, generics offer amazing code reusability. So in plain English, reusability means great to write less code. So when you write generics, when you implement generics, you in essence write less code. So less and less and less, because you write the Quicksort once, and then you can call it with an array of numbers, with an array of, as I said, cats and dogs and reports, or what have you in your requirements. So this is the actual idea of reusability for generics. So this is it. If you have questions, please let me know in the comments down below, because I read the comments. If you don't understand something in this code, please tell me, because I want to have a thorough explanation of this code. So again, the aim of this video is to show you the code and explain like how this works and use the debugger. And also there are many people that don't want to put the questions, but they actually have the questions. So be you the first one who actually writes the question down below, and I can respond to it. So if you like this video, please click thumbs up. Also, if you want to see the extension method, the extension version of this, don't forget thumbs up until 30 likes, okay? Until next time, bye guys.